Thank you. The mic, okay, good, the mic is working. So, I don't have a title slide. I don't have any slides. There we go, okay, excellent. So, I've been a programmer for about 30 years now, and I have written a lot of code in that time. I'm not super prodigious or anything, it's just, you can do a lot in 30 years. And some of the code that I've written is crappy, not very good, and some of the code that I've written is really quite nice, if I do say so myself. And a lot of the code I've written is just ordinary, mundane, mediocre, boring code. But the code that I'm proudest of, the stuff that I really love, is the stuff that I've sweated bullets over, or sweated blood over, and it's the code that is not merely or not necessarily usable to end users, but reusable by my peers, my fellow programmers, you folks. I don't know why, that's something that's what motivates me. Some people love writing an amazing user interface. Some people love incredible mathematical abstractions. I just like writing good libraries that can be reused by my peers. And over the course of a couple of good ones and a lot of okay ones, I've learned a few tricks. I've learned things not to do, things to do. Some of these I've probably been taught to me on mailing lists or in classes. Some of them I've read in books, and some of them I've just figured out by repeatedly doing things wrong and eventually figuring out, ooh, it works better if I do it this way. So I thought I would distill some of that experience down and share it with the rest of you. But before I get to that, I want to take you back in time to a distant, vanished age, an earlier era. Who remembers the early 90s? Oh, sorry, that's the wrong 90s. I'm talking about this 90s. When a new golden era was upon us, or a new golden age was upon us, this amazing wonder technology called object-oriented programming that was going to save the world, change everything, usher in an amazing new way of thinking about software, making software, where everything would just be magically reusable and extensible because objects. Well, this was mostly not really true. It was just people making stuff up and writing magazine articles and books without really being very informed, because it was a new technology, and it looked good on paper, but we didn't really have the experience to see that, well, no, it's not magic. So anyway, a lot of people drank the Kool-Aid. I admit, I drank the Kool-Aid myself for a couple of years before I figured out, oh, it's not magic. It's hard work to write reusable software. Some people actually drank the Kool-Aid continuously for 15 years, and that resulted in a thing. There's a Java library that contains a class called an abstract singleton proxy factory bean. If you don't understand what that means, that's okay. It's clearly explained in the documentation as a convenient proxy factory bean superclass for proxy factory beans that create only singletons, and that clears it right up. So that's what happens when you drink the Kool-Aid of object-oriented programming for too long. But it turns out there are no silver bullets. This was an article published in 1986, 5 or 6 years before the whole object-oriented craze took off, in which Fred Brooks observed that there's no one single magic wonder technology that's going to solve all the problems with software development. He made an analogy or a comparison to hardware engineering, where Moore's law just sweeps problems away every 18 months. It doesn't work that way in software, unfortunately. And Fred Brooks was right. There is no silver bullet. Functional programming is not a silver bullet. Coroutines are not a silver bullet. What are the other flavors of the week? Pick whatever you like. It's not a silver bullet. Nothing is going to change the world dramatically. Object-oriented programming didn't do it. Today's flavor of the month won't do it. Next year's flavor of the month won't do it. Instead, the way that you write reusable code is through hard work. It's not free, but it's not magic. It's hard work. It requires forethought and attention to detail. I'm not a super genius programmer. Like I said, I have written some nice software in my time. I sweated bullets to write that software. It took really hard work, which is probably why I'm a little inordinately proud of it, because it didn't come easily. But if I can do it, you can do it. And you can learn from my failures, maybe even learn from my successes. So before I present my wonderful list of principles of writing reusable code, it's not always necessary. It's not always desirable. Do not fall into the trap of thinking everything must be a library. This is something that happens in languages like Python, Java, C#, where there's less of a distinction between library and application. So much of your application code just goes into source files that look like library code. It's very tempting to make everything a library, or to think that everything has to be reusable. It doesn't. There is absolutely nothing wrong with writing one piece of code that solves one problem that you need to solve today for this application. That's absolutely fine. Now, if you do that 6 times over the next 4 weeks, and all those pieces of code look really the same, maybe you need to step back and think about a reusable solution. But don't fall into the trap of thinking you always have to write beautiful, wonderful textbook reusable code. However, when you do need to do that, when you have discovered a repeated pattern in your code and you want to write reusable software, here are some principles I have discovered. 9 is not a special magic number. It fits nicely on this slide. It fits nicely in a 25-minute talk. I could probably come up with 90 principles if I wanted to, but that would be a bit excessive. I could probably come up with 15. I could probably trim it down to 5 if I only had a 10-minute talk. Anyway, this is what fits into a 25-minute talk. So I'm not going to insult your intelligence by reading the list of principles at you. Instead, I'm going to insult your intelligence by reading the bullet points on the slides about each principle. I'm just kidding. So number 1, it's nothing to do. I mean, one good way to write reusable code is to write better code. Be a better programmer. And there are a lot of ways to become a better programmer. Something that we don't really emphasize very much in our education system or in our culture of, at least in industry or academia or anywhere really, is read more code. This is something that Greg Wilson has been on a kick about for many years now, and it resulted in the 3rd book here, Beautiful Code, which is, I have to confess, I'm only halfway through it because I'm not a super genius, and reading stuff like this takes me a long time. It's hard work. It's worth it. It's a really good delve into some real-world systems, how they work, and how they're written, and how they're designed, and why they work this way. What are the competing forces in real, actual live software, not some academic textbook exercise. The other 2 are older and timeless. A good book about software is not about the programming language of the month or the library of the week. It's about general principles, and all 3 of these fit that bill. They are timeless classics, highly recommended. Write more code. Yes, if you do something a lot, you will get better at it. But something about writing software requires you to write code and revisit it, make it better. Critique your own code mercilessly. Refactor your own code ruthlessly, because if you don't, somebody else will. And it generally hurts less if you're a little merciless to your own code first before somebody else is. I kind of, conflated the 2 bullet points about reading more code and reading more books, whatever, you get it. Finally, do not, please, please, please do not try to learn to program from Google. There's a lot of good stuff out there on the internet, but it's really not the way to learn how to program, if that's what you're here for. Okay, so a little more concrete, useful advice, everyday advice, I think, is don't write a class when a function will do. People coming from, or people still trapped in languages that only have classes often fall into this trap. Everything must be part of a class, therefore everything must be object-oriented, must be a class. No, there's nothing wrong with functions and subroutines. They're an extremely useful tool. People wrote lots of really handy, good, reusable software before we had classes and objects. However, don't go overboard. This is not a rant against object-oriented programming. It's a great technique to have in the toolbox to use when it's appropriate. So when you need a class, write a class. When you don't need a class, don't write one. So I want to show you an anti-pattern, or maybe a code smell. Code smell is just something that maybe needs attention. An anti-pattern, uh-oh, we have a problem here. So this is a class that does one thing. It loads things from a source of things. And this, so the code smell is when you have a class with only a single public method, and it's a downright anti-pattern when that single public method is the only thing there. If this thing loader had 600 lines of tricky, intricate code buried in 17 private methods, I'd say, okay, yeah, that can be a class. It smells a little bit funny because of the single public method, but if it's one public method called load, it's 10 lines long, and that's all there is no reason for this to be a class. Just make a function. That's my 60-second version of a great talk Jack Diederich gave at PyCon a couple years ago. Highly recommended. It's both informative and entertaining. I would dig that up. Now, the flip side of that, somebody might watch Jack's talk about stop writing classes and decide, oh, we should never write classes ever again. No, because a class is just a bunch of functions with some shared state that all operate on that state together. That happens all the time in programming. That's why object-oriented programming was invented. So if you have a bunch of functions that all have a connection and load and save and make queries about articles or things or foobars or whatever, well, that's a class. Make it one. So it's just a small syntactic change when you're using a language that supports classes. So do it. Take advantage of the features the language provides. Don't be dogmatic. All right, I'm old enough that when I was in high school and early undergraduate career, Pascal was the teaching language of the day. Things have moved on. We have better teaching languages than Pascal nowadays, thank goodness. But Pascal had a really interesting feature. I think we've lost, at least those of us in the mainstream imperative programming community have lost sight of this, the distinction between functions and procedures. In a nutshell, functions compute stuff, procedures do stuff. Procedures have side effects, functions don't, or really shouldn't. So your mainstream imperative programming languages, including Python, do not care about this distinction, which is unfortunate. You should care, even if your language doesn't. And the way I remember this, the way I keep this in my head, is a very simple rule of thumb. Every function should either return a value or have side effects. Do not combine both. I am not anti-side effects. You cannot write software without side effects. Just don't combine them in the same function. Some things have side effects because they do stuff. Some things have return values because they compute stuff. Just draw a nice clear line between those two and we'll all get along fine. So here's an anti-pattern that you often see in C code. I've deliberately not written this as C because you'll see in a second the solution to this can't be done in C, unfortunately. C programmers are notorious for this sort of thing. It's a performance hack because really the main reason to program in C is that you're obsessed with performance. So of course you're going to have performance hacks everywhere. You have a function that operates, modifies, mutates something while returning a value that is derived from that computation. This function is not as reusable as it could be because of that mixture of side effects and return value computation. It's not just C programmers that do this. 3-4 days ago at work, I was reviewing some code from a colleague and spotted this or something very much like it. It's a query function that returns a dictionary unless you pass in a dictionary, in which case it mutates that dictionary and then returns it, which is the sort of thing that C programmers do a lot too. You don't often see it in Python code because it's a performance hack. I suspect it was written this way to avoid the terrible expense of updating an existing dictionary from the return value of this one. I'm sure it saves microseconds at runtime. And if you care about those microseconds, I'm afraid you're using the wrong programming language. Yet I mean, yes, there are times and places in Python when you should care about the overhead of creating a dictionary. This is probably not one of them. So a better way in both of these cases is just have a return value or just have a side effect. So the string munging example, you don't mutate the existing string, you return a new one with the change that you want. Yes, That's more expensive. You have to allocate a new string and copy it. I'm sorry, it's also reusable. If you value, sometimes you do value performance over reusability, so screw reusability and go for performance. But if you want reusable code, sometimes you have to sacrifice performance. And the Python example, it just gets so much simpler in every way if you just return the new dict. Frameworks are nice, but generally libraries are nicer. And the difference is that with a library, you, the programmer using the library, is in control. With a framework, the framework is in control, and you're merely supplying code that you really hope the framework will run just in the right way you want it to. And using a framework is typically an all-or-nothing proposal. You can't just say, oh, there's this nice little bit of request parsing code in Django that I need. I'll just call that function, because you can't. It's buried deep in a framework, and if you don't swallow the framework whole, too bad, you can't reuse that code. So code that just, if you just want to have it, somebody, why doesn't somebody just write a library of request HTTP header parsing? Because that's nice and reusable. Don't go overboard with these ideas. I'm not anti-object-oriented programming, despite the jokes in this talk. Classes are not evil. Neither are side effects. Side effects are inevitable. You cannot write software without side effects, whatever the Haskell people tell you. And certain problem domains really scream out to constrain the application developer. I'm looking at you, web development. Why do you think there are so many web frameworks? Because web development really benefits from following a carefully controlled garden path. Frameworks are not evil. They're just less reusable than libraries. They're still a good thing to have. So when you're writing this library, I hope, or maybe framework, one temptation you must avoid is the temptation to solve everything. If your library is popular, even if it's only popular among your coworkers, 6 or 8 or 10 or 50 other programmers, or if it's popular with hundreds or thousands of people all over the internet, you are going to get requests to add features, enhancements, change things. Avoid the temptation to handle every single case, because there's the risk that you will get something wrong. And when you get something wrong in a library, who can remove that bit of ill-advised code? Well, in the general case, nobody. Because of backwards compatibility constraints, you're stuck with that wrong code forever, and so are all of your users. Whereas if you leave something out, who are the users of your library? It's your fellow programmers. Who can write a little bit of code to do what your library doesn't do? It's your fellow programmers. Writing a library is not like writing an application. The users of an application generally can't extend it. The users of a library are the best people in the world to extend it. Testing is not optional. Testing is not some flavor of the week, crazy new idea, or automated testing, I should say. It is absolutely mandatory for any sort of reusable code. If you claim to provide a library that I can use in my application, and there are no automated tests that I can run, I'm sorry, that is not a library, that is not reusable. Please return to the starting point, collect $200, go around the board again, and write some unit tests. Then maybe I can reuse your library. Automated tests are not sufficient, but they are necessary. Documentation, take that previous slide and repeat with substitute tests for documentation. It is not, it's just, you can't supply a library without documentation. The absolute bare minimum is the inline reference documentation, doc strings, that every modern programming language gives you. You have to give a little bit on every public function, every public module, every public class, what's it do, what's it for, what's it return. But that is the bare minimum. Please, please, please take the time to supply some narrative documentation, a code walkthrough. How do I do X? If it's a small library, you can probably do that in your README file. It'll probably take you 10 minutes to write, and the users of your library will be saved many hours of head-scratching and confusion and frustration and realizing, oh, I guess I should have used a different library, one with documentation. Finally, extensibility and reusability are not the same. Oh, sorry, I meant to So the 2 points about documentation and testing actually feed back really nicely on the point about this, conflating return values and side effects. When you document every public method or function scrupulously, you discover the weird, strange corners of your API, like there's this optional foo. If you pass it in, it will be populated and returned instead of a new dict. It takes longer to explain that in English than to implement it in Python. But I must explain it in English because that is what documentation is written in. If documentation was written in Python, we wouldn't need documentation and we'd all be interpreters. When it takes longer to express something in natural language than it took you to express in code, it's probably too complicated for the API. The other thing is, when you have a feature like this, you've just doubled the size of your unit tests. There's more features. You have to test, okay, what happens if I pass in foo? What happens if I pass in a string, a list, something bogus for foo? What happens if I pass in a dictionary that's empty, a dictionary that's not empty? What are conflicts like? Oh my God, okay, so I've probably just increased the size of the unit tests by a factor of 10. Whereas this version, a pure function that just takes some inputs and returns some outputs, that's dead easy to test. Oh, it's also really easy to document, one sentence, and it's reusable. Win, win, win. So writing documentation and writing tests is a really good way to find the ugly, nasty, hairy bits of your library that you probably didn't think hard enough about when it was just code written for that one application and it wasn't yet reusable code. Finally, extensibility. This is not a talk about how to write extensible code because I don't actually know how to write extensible code. I've never really done very much of it. If you know how to write extensible code, please come up here and give a talk on it. I'll be first in line to see it. I'd love to learn your tricks. So this is another one of those things that the snake oil salesman from the 90s promised about object-oriented programming, that if we all started using Fortran 95 and Visual Basic 6, extensibility, reusability would just magically, no. It didn't happen. I fell for that. You can actually see the results of my tomfoolery in the Python standard library. I apologize for that. But it's not true. It doesn't work that way. I suspect that writing extensible code is also hard work and difficult, but not magic. But I don't know. I'd love to have somebody come and give a talk on that because it is a different property of software, independent, orthogonal to reusability. So, no such thing as a free lunch, I'm afraid. There's no magic pixie dust. There's no wonder technology that's going to solve all the world's problems. 20 years ago, it wasn't object-oriented programming, and today it's not functional programming or asynchronous programming. They're all useful, absolutely good tricks to know about, good tools to have in the toolbox. They're not magic pixie dust. Good anything, good software requires hard work, and that applies to reusable code. I strongly suspect it applies to extensible code. And finally, beware of clueless pontificators, pompous windbags, snake oil salesmen, and people who give talks at conferences. Thank you. We have time for questions.
All right. So we have a few minutes for questions if you want to pick Greg's brain.
What you were saying about returning a value versus side effecting, I completely agree. I was just wondering about it's kind of an edge case. I see a lot of functions that return a Boolean that's basically, did you do the thing or not? And it's not really like an exception exactly. It's just, it's fine if you didn't do it. I would just like to know.
Yeah, I've done that myself. That's a pattern I use myself. But you know, it's a pattern I tend to use in non-reusable application code. I think I'd rather not do that in a library. I'd rather not see that in a library. There's nothing wrong with it in single-purpose application code, though.
So would you rather throw an exception?
Depends on circumstances.
So, I mean, I suppose iterators do throw exceptions at the end, right? Even though they're always going to do that.
Yeah. stop iteration is a little bit of an abuse of exceptions for control flow. That's the sort of thing that makes anti-exception people really makes their skin crawl. So
Okay.
it's probably not a good justification for exceptions.
Okay. So no magical solution there?
I don't have a magical solution, no. I'm all out of magic pixie dust.
Hi, thanks for the talk. There's a lot of buzz right now about, well, it used to be SOA, now it's microservices. So specifically for sharing code between applications that may or may not be related, but have common use cases, do you have any guidelines or pitfalls or anything like that?
Well, I don't think everything can be a microservice. I suspect at some point you have to write a library. Like if all your services are written in the same language, you're going to have some common code, and a library makes a lot of sense. Just have some shared code. It's not the end of the world.
Just extract a library and
Absolutely,
share.
absolutely.
Hi, I just want to say awesome talk. I love the slide about functions versus procedures. Thank you so much for bringing that out. It's amazing. And not everything has to be a class. Great work. Thanks a lot.
Thanks.
Yeah, also thanks. Great talk. Loved all the stuff. How can I convince other people that it is actually valuable stuff?
Well, I think, have you convinced them that reusing code is a good thing?
Working on it.
Okay. Me too. Yeah, you're not suffering alone. Yeah, I think convincing people, step one is convince people to factor out common libraries instead of constantly duplicating code. And step two, probably concurrent with step one, is say, oh, look, if you make this little change to your library, the tests are smaller, the documentation is shorter, oh, and it's more reusable.
Yep.
I'm literally through this process at work in the last week.
Okay.
I wasn't the one who suggested factoring out the library, but I was the one who spotted some of the flaws in the API. So,
Okay.
it's hard work. Do it. Keep at it. Don't give up.
All right. Thanks.
Hi, I'm wondering where I can learn more. So what I'd love to see is an example of, say, a tool that doesn't work, that can be changed. So I see the initial code there, I see the changes that I made, I see how it's used. Do you have examples like that?
So the 3 books that I referenced are pretty good. They're test-driven development. I think somebody wrote a book on this like 10 years ago. It was popular in the Java community. I can't remember who wrote it. Just search for books called test-driven development. I'm pretty sure they're out there. Sorry?
Beck wrote that book.
It was Kent Beck?
Yeah.
Okay.
Great, thanks.
Yeah.
Hi, thanks for the talk. I especially appreciated the articulation that if you have a bunch of related functions with shared state, then a class is good for that. I was wondering, I remember last year at Eric Rose's talk about, among other things, API design and library design, he talked about start with a use case. Like instead of trying to write frameworks and libraries from scratch, start with the use case of what you wanted to accomplish and then pull abstractions from that. Can you speak a little about that?
Absolutely. I think it was the people behind Ruby on Rails who coined the phrase, don't create frameworks, extract them. Yes, another way of saying the same thing. Start with, and yes, libraries should have use cases just like applications should.
And so when you're writing reusable code, I mean, does that mean that the implication should be that maybe at first it's okay that sort of my first draft is not, quote, reusable until after I've sort of used it in the wild or in production enough that...
For sure.
Yeah,
Yeah, absolutely. Especially if you're writing a library like within your company, you have a lot more freedom to make incompatible changes. And by all means, embrace that freedom. I've done it. What was the other thing? Oh yeah, something I have done occasionally, not enough, I should do it more, is write the documentation for your library first. The narrative, here's how you do stuff, and it forces you to think about what's the use case for this library. I think it's a good tech. It's similar to writing the tests first, but it's more chatty.
Thank you.
Yep.
All right, thank you very much, Greg.
My pleasure.